Thank you so much for having me here, and thank you, Margot, for introducing me. Good afternoon. Good afternoon. Great. I'm glad that my talk is not before lunch, but it's after lunch, but I'll hopefully keep you all awake. It's fantastic to be here and talk in person in front of all of you, and also a warm welcome to folks who are listening online. So as part of this keynote, I thought, we're hearing so much about AI and machine intelligence that I really just wanted to talk about what really makes these tools intelligent, especially for data visualization. And so as part of this keynote, I will walk through some various examples, try to motivate where humans are really good at and where they may need some help, and just walk you through a journey, and hopefully you'll get some takeaways that you could probably take to your own organization and apply it in your own work. So let's get started. So just walking through some early inventions, the first one that comes to mind are tools. And tools are inventions that happened way before the Homo sapiens walked the earth, more than 2.5 million years ago. And they have been really profound in helping people do work more efficiently and just being overall more productive. And we can't really forget the compass. I mean, the compass back in the day was really critical in helping people navigate and find new places with discovery. And it's really an essential aspect of wayfinding. And this bright idea, where Thomas Edison took metal filaments to produce light, really changed how we go about doing our work. Light is pretty much an essential aspect of our life, and it's really hard to think about what we would do without it. And I wanted to throw in a more kind of a fun invention, movies, which is sort of an umbrella topic for a range of inventions, starting from mechanical slides, figuring out how animation works, graphics, sound. And I thought this was kind of relevant, especially for a lot of us who were hunkered down at home. I was Netflix binge watching a lot. Probably a lot of you too can kind of relate to that. But a lot of the cluster of inventions, particularly in movies, really opened up the space for what humans do best at. We like to ideate, we like to create, we like to analyze, and we like to imagine. So the cluster of inventions here really help empower humans to do what they're best at. So let's figure out what does this all mean with respect to how humans are with data and patterns out in the world. So let me walk you through an example. So here's a table. This is a table of products by region, which shows a bunch of prices. And if I ask you a question, go through this table and try to find out the product that is least profitable. And as I ask you this question, you're probably scanning this table from left to right, up and down, trying to make sense of it. But let me make it easier for you. What if I highlight these numbers in red that are not doing well? All of a sudden, your eyes go to the red, and you're able to read these numbers, but you still have to do a mental comparison in your head, taking these 4-digit numbers and trying to figure out which one is the lowest. But then if you take this table and convert it into a simple data visualization, the patterns are immediately clear. The amount of profit is on the hue of red, and you can actually look at the amount with respect to the length of the bar, and your eye immediately goes to the relevant bars to make that judgment. So the point that I'm trying to make is the human visual system is a really strong and powerful entity. And we're very good in making sense of information and patterns by taking advantage of our human visual system. So there have been a cluster of really good, inspiring examples from data visualization that has really taken advantage of this very premise about the human visual system. So let me present to you an example that has really inspired the visualization community. So Charles Menard sketched this visualization back in the day, and this is a visualization that really talks about the beginning of the end of the French Empire. So let me walk you through the story. So Napoleon, in June 1812, gathered his army from Poland on the west and was moving towards Russia to invade Russia. And the orange line that you see from left to right, west to east, indicates the number of troops. And as you see, the width of this orange line diminishes. And so the Russians were pretty good at fighting against the French, and the army dwindled. And finally, when Napoleon reached Russia, the Russians had abandoned their capital. So there was really nobody to surrender to Napoleon. And so he had to head back with his troops. And by then, the harsh winter had set in, which is indicated by the line graph at the bottom of the visualization. So Menard really skillfully wove in the temperature along with the number of troops. And the black line represents the troops heading back to Poland, to the west. And you see the thickness of that black line is substantially thinner than the orange line. And the combination of fighting against the Russians, the really cold temperatures, resulted in pretty much the French army getting wiped out. So this is a really skillful way where Menard very quickly learned how the human visual system makes sense of color and patterns and the juxtaposition of images to communicate a data story. Now, why am I saying all of this? The point that I want to make is, there are a couple of points actually. As humans, we are innately curious about the world. We want to make sense of it. We try to find patterns. We try to glean meaning out of these patterns. And we really have a strong visual system that supports that. So in a sense, we are all our own Sherlock Holmes. And so as part of playing that role of a Sherlock Holmes, we're really, really good at analytical thinking, which is a structured approach in trying to answer questions and making decisions about what we see. And I'll walk you through a couple of examples where people in their regular activities play that role. So this is a Tableau visualization. It's a woman who is a biker, and she realized, that she hasn't been biking that often, and she decided to take a new route in a new neighborhood in Seattle, and decided to use Strava to log her bike rides. And she put out this dashboard, and she asked herself this question: am I riding more recently? Here is another example. This is a dashboard, again in Tableau, that was created by this organization called NetHope, which was really looking at ways in which it could coordinate medication for Ebola between profit and nonprofit organizations in Sierra Leone. So this is a set of charts that people on the ground use to answer this basic question: is the medication program working? And if not, what can be done? What are we seeing? What are the patterns? So these two examples, including the one that I showed from Menard, really takes information on one end and tries to weave in stories on the other end. And as readers, when we look at these examples, we only see the stories, but there's so much going on behind the scenes. For these users to actually create compelling and useful data stories to communicate to themselves or to an audience, there's a lot going on. The data needs to be connected. We heard in the panel earlier before lunch that there's a lot of dirty data. It needs to be transformed. It needs to be cleaned. There can be missing data. And there's so much that has to be done behind the scenes in order to create these stories. So how do we actually come up with tools that can automate some of these pain points so we can really get the human or the user to do what they really enjoy doing most and what they're good at? In other words, how do we create tools that can support a human in their analytical reasoning? So I present 4 main ideas, and I'll try to address these in the various research examples that I present during the talk. So the first one is we need tools to support the cycle of analysis. And analysis is not linear. It goes through so many processes. People go back to the data, import more data, try to connect it with existing data. And these tools need to help answer a question by composing a picture. And these pictures need to be meaningful because the best visualizations really support a task or an intent that the user has in mind. And finally, I mean, these tools have to also be easy to use. You can't have a complicated Swiss Army knife that can do everything, but it's simply hard to use. So given those 4 main ideas, I'm going to walk you through kind of a vignette flow of different aspects in which tools can be used to help users see and understand their data. And as you see here from the left, I start with a really solid line, and it gets jagged towards the end, which indicates these are kind of more speculative, future-forward ideas. So let's get started. The first aspect is data encodings and transformations. So a big piece of creating meaningful visualizations is really figuring out the meaning of the data and coming up with sensible ways of representing and transforming that data. And I will say that semantics plays a really important role in transforming the data into a form that is meaningful. And what is semantics? We all know that, as we're trying to make sense of the world and figure out meanings and patterns, it's really an abstract concept. And semantics is a way to take that abstract concept and try to operationalize it. So it really tries to formalize the notion of meaning. It tries to take into account the context and the task of the user and trying to make this information meaningful. So let me walk you through an example here where semantics, a little bit of semantics, actually goes a long way in making a chart meaningful. So this is a plot of brain and body mass created by Carl Sagan. It's called the Sagan plot, commonly in the community. And as you're trying to make sense of this chart, your eye is probably hovering over the blue dots, the labels associated with the dots. Because of space, some of the labels are shifted, and you have to look at the arrows and see where they're pointing to. But if you have an algorithm that can take those labels and replace it with semantically meaningful icons that represent these various animals and birds depicted in the chart, all of a sudden the patterns become more meaningful, where you might see this blue whale in the extreme right corner and the hummingbird at the bottom left. Another example where algorithms can really play a role in meaningful data transformations by just understanding the semantics is parsing dates. For those of you who have traveled from other countries, you probably can see this with dates. I mean, at least from India, we follow a different format when compared to those over here in the US. And it turns out that parsing dates is a gnarly problem. There's simply a lot of formats. And so the problem that a lot of users have when they're representing their data is importing a table, and quite often these dates are represented as strings, and they need to figure out not only which of these columns need to be marked as dates, but what is the format. And At Tableau, we identified that that was a common problem, and we wrote an algorithm that tries to automate that. So if you look carefully at these dates in the column that I've highlighted by the red box, you'll see the second row, which says 4/15/08, and you're like, yeah, I mean, there can't be months more than 12, so that's a month, date, year format. And so we took this and we implemented an algorithm where the system looks at the context of dates rather than an individual date and tries to come up with an automated way for detecting the date format. And you might say, you know, this is really simple, but this really goes a long way because people don't want to be distracted from their main goal when they're trying to create these data stories. So these little defaults that where a system can actually cooperate and work with a human goes a really long way. Another aspect of data transformations are joins. So quite often when people are importing their data to create a visualization, they draw information from multiple tables where they try to join these tables along a common piece of information. And a lot of the previous literature around joins tend to be what we call equijoins, where the strings or the data values are equivalent in both tables. But if you look at this example, both these tables have a country column, but their formats are different. One is a country code and one is a country name. And we see this for a lot of examples, including currency. You might have a table in US dollars and another in euro. So these are what we call semantic joins. So for a computer to actually identify these common semantic properties, it needs to understand that they share some shared meaning, and it comes up with a suggestion as to how these tables can be joined. So given that, that aspect of using tools for data transformation, I'll walk you through a few examples around question and answering. So a common way that people interact with data is asking a question in language. So I'm looking at earthquake data, and I'm here in the Bay Area, so earthquakes are a topic of concern. And I ask, find large earthquakes near California, and the system highlights a bunch of earthquakes with large magnitudes in this area. And I can ask a follow-up question, how about near Texas? And notice that I didn't specify large earthquakes, but the system understands the context of my previous question and is able to respond accordingly. And these sorts of questions get more nuanced because I could ask for trends in the next month where the system will have to connect the question to a forecasting algorithm under the tool. And there's even more complications around language. So let me walk you through another quick example where I might have a table of housing information, and I ask a question, show me house prices. Here, prices maps to the attribute price, which is an easy thing for a system to do. But then what if I ask, show me expensive house prices? And here, expensive does not map to a particular column in the table, and the system will have to pull up the definition for expensive and reconcile that to price, and more specifically, high price, in order to understand the question. And then it gets even more complicated if I ask a question, show me large houses, and when the system pulls out the definition for large and tries to look at the definitions for all the attributes, it has to figure out the common words in these definitions to map large to an appropriate attribute. And so as we see here, for these tools to be intelligent, external knowledge is really important. And these are some corpuses that a lot of tools tend to use, like Wolfram Alpha or Wikipedia, where questions that support units like Fahrenheit and seasons like fall can be properly interpreted by the system, even though it's not in the data, to show a sensible visualization response. In addition to asking questions about the data, people also might ask questions about the visualization or the dashboard itself. So a query, what's the spike in that blue line, is actually more complicated than you may think, because spike has to be mapped to a line chart. The word blue has to be mapped to a color property, in this case, the blue line for townhome, in order to show an appropriate result. So just as tools need to understand what a user is asking, we also need to think about tools that can help a user even ask a question in the first place. And we're all pretty familiar with autocompletion. We use that when we're searching on Google or we're trying to buy a product in Amazon. And so the question is, how do we create tools that help users ask the right question for data discovery? So this is another piece of research that came out of Tableau, where I'm looking at COVID cases, and I ask, show me cases in, and map widgets show up that provide a sneak peek into the underlying data so that I can complete a question. So I kind of quickly walk you through this journey of data transformations and question and answering. And then the next aspect of it is really figuring out the nuances between language and charts, because just as important for a human to be able to ask questions about their data, a machine needs to respond appropriately as well. So kind of revisiting a similar example that I showed earlier, if I'm looking at disease outbreaks around the world and I ask a question, show me the orange spike, sure, the system can find the appropriate part of the chart that's relevant, but as part of that process also needs to generate a pithy annotation in response that provides a little bit more detail to answer that question. And questions like drop in July 2016, when I'm looking at pound versus dollar, would require the tool to go out to the web, figure out that it was actually due to Brexit, parse that data, and present a response back to the user. Data summaries have become really popular now. This is a data summary created by Narrative Science, which was recently acquired by Tableau. And it's really useful to create these insights and reporting. Interacting with text and charts is also important for people to read the text that accompanies these charts. So lastly, as we move to other mediums like Slack and chatbots, the medium really becomes the message in terms of communicating with data. And we all probably have an Alexa or a Google device at home, so that really changes how we explore and interact with data as well, and this is kind of more future-forward work. So to wrap up, I provided a bunch of examples to really impress on ways in which tools can work with humans to support humans in terms of what they're good at. And I'd kind of like to end this talk by saying, there's a lot of data enthusiasts out there who are intrinsically analytical thinkers. So how do we actually create tools to support these people and provide smart defaults? And with that, I'd like to end my talk. These are some details if you want to reach me. And just a shameless plug, I have a book coming out with another female author who's pretty kick-ass. And it's end of summer. And yeah, feel free to reach me afterwards, and I'd love to network. So thank you very much.
Thank you so much for the wonderful talk.